So the final one, the tangent wave, or the tangent function that we want to look at. Ready? The tangent function. Again, we've got some point moving around anticlockwise in a circle. What I'm interested in is this time the tangent. If you remember what the tangent's to do with, it's to do with the ratio of the opposite side to the adjacent side. Tangent is opposite over adjacent. The other ones were to do with the ratio for the sine function between the opposite and the hypotenuse, this one. So it's all to do with some side divided by 1. So that because it's always divided by 1, it's just this side effectively. And same for the cosine. But the tangent is different because this time it's nothing to do with this hypotenuse. It's to do with the ratio of this side to this side. So what I do is I think about measuring at any point. Let's say it gets to here. How do I find the tangent? I measure this length, how far has it gone up the y-axis, and divide that by how far it's gone along the x-axis. So as it comes further up, you can see that I'm actually dividing a large number by a small number. And the closer I get to the top, the smaller the number underneath I'm dividing it by. Until when I get to this point, I'm dividing by 0. Because there's no distance along this x-axis, and that has a consequence. So at this point I'm dividing 0, because that's no distance up the y-axis, by the distance along the x, which is just 1. What's 0 divided by 1, or 0 divided by anything? 0. So the tangent of 0 is 0. Question for you now, I come round here. At which point will the tangent of the angle be 1? At what angle has got a tangent of 1? 45. Who said that? Right. Why 45? Because that's where... no, not where it's... at this point here, it's not where it starts. It starts here. You're right about the angle, though. If at 45 degrees, that side and that side will be the same. So if I divide one by the other, I'll get 1. So the tangent of 45 is 1. So if I go to my scale here, I can put 1 in actually. 45, which is this point, has got a tangent of 1. So if that's 1 on my scale, I can put a cross there. The tangent of 45 is 1. I know that point on the tangent scale. What's the tangent of 0? Right, so I know those 2 points. Let's carry on going round now. So we get to here, and this is the first time it gets really interesting. If I divide anything by 0, what's the answer? How many zeros can I get out of 1? How many lots of 0 are in 1? 0. Infinity. I can get as many zeros as I like out of 1. If I divide 1 by a smaller and smaller and smaller number, the answer is getting bigger and bigger until eventually it's infinite. So actually, the curve at 90 degrees goes off to infinity. So at this point here, we have what's called an asymptote. At 90 degrees, we draw in a dotted line, and this is called an asymptote. And the curve approaches that but never crosses it. So what we have is a situation where the curve does this and shoots off up towards infinity but never actually crosses this asymptote here. It just approaches it. Now let's look back at our circle. At this point here, we're at infinity. I go just a slight distance beyond there, and what happens to the sign? Now this is negative number. That's the opposite side is still positive, but the adjacent is negative, so it goes negative. but a negative really big number. So in other words, it's coming back from infinity, but a negative infinity. So it flips. The curve flips to negative infinity. It's almost as though it's gone around the universe effectively and coming back from infinity. And so the curve comes back from infinity and then comes round again. Do we know any points? Do we know any points? When is it 1 again? At which point is it 1 again? When that side is the same as that side, what angle will that be? 90, not quite, it's this angle. 90 plus 45 is 135, right, so 135 degrees, or at this point radian wise, which is, if that's pi, and that's pi over 2, it's 3/4 of pi in other words, then we know that's 1. So we know at this point we're back, sorry, not 1, minus 1, so we're here. So it comes back from infinity, goes through that point, and then reaches 0 again at pi, and then repeats. Goes up again. There's another asymptote at 270 degrees, so it approaches that line but never crosses it. So my curve's not brilliant there. And then comes again back from infinity towards there and finishes at 2 pi. That's our tangent wave. So on autograph, finally, we can type this into autograph, and you can use autograph in the assignment, by the way, to plot these things. So let's look at it. Oh, already got that there. So y equals tangent of x. It only recognises x, so you can't put theta in. Hit OK, and we get our tangent. And again, if I'm in radians, which I am, and I hit default scales, then you can see that at 45 degrees, look, which is pi over 4, we've got a tangent of 1. At 270 degrees, or 3 pi over 4, we've got minus 1. And apart from that, it just approaches infinity at certain values. So if you type in your calculator tangent of 90 degrees, what happens? So in the tangent curve, we can get angle tangents bigger than 1, look. The tangent of this angle is greater than 1. So it's nothing to do with the radius this time. We are, in the other ones we were looking at, we were limited by the value of the radius, because that's the maximum it could be. In the tangent, we're dividing the opposite by the adjacent here, and that can be greater than 1. In fact, it can be infinite. So tangent of 89, for example, is about 57.